All right, before today, we are still looking at graphing, but we're looking at how a graph can help you solve an equation, which I know when I used to do like air test prep with kids, this is like where if you know how to use that calculator and you're retaking the air test, honestly, about half of those questions on the air test you can answer just by knowing how to use the calculator, which is, for me, a really bad test because it doesn't really know what you know. It just knows, can you use the calculator? But we play the game in life, right? We do what we have to get through. So if I asked you to solve that equation, good, you'd move the 8, right? Hopefully that one didn't trip you up too much, right? If I asked you to solve, you would add 8. So 2x equals 8. Good, you would divide by 2. And x equals 4. Yay. Now, knowing how to solve by hand, great. But did you know that you could actually solve that by a graph? And you're like, why on earth would you want to graph that, right? Well, it's because I know I'm trying to build some connections now because I know what's coming in the future. Okay, so if I can learn those connections now when it's a basic concept, when we get to the harder stuff, it'll be that much easier for you. So we can look at the equation graphically. So to do this, you will turn 2x minus 8 equals 0 into its related function. Okay, so when you hear that term related function, all that means is take the 0 that it's equal to and replace 0 with y. That's all that means. Okay, so once your equation is set equal to 0, take the 0 away, put in a y, and now I can graph this. So what would be the slope of this line? 2 over 1. Okay, the slope is 2 over 1. And what's the y-intercept? Negative 8. All right, so your first point would go at negative 8. And then you'd go up 2 over 1, up 2 over 1. Right? So there is the graph of it. What do you notice about the solution that we found and then its graph? When we solved that equation, what did we say the answer was? When we solved it, you added 8 divided by 2. It's 4. Let's look at the graph. Yeah. You were solving it for x. This is the x-axis. It crossed the x-axis at 4. The answer was 4. Come on, nobody else was like, wow, impressed by that? Wherever your equations cross the x-axis, those are your answers for x. So solutions to the equations can be found graphically by finding that is known as the x-intercept of the graph. Right, you're solving for x, it makes sense that it is the x-intercept. So steps to do this, because this is what we're working on today, guys. Rewrite the equation in the form, maybe. Really? No, it worked earlier. All right, so rewrite the equation in the form, there it goes. Ax plus b equals 0. Okay, ax plus b equals 0. In other words, you're just setting the equation equal to 0. Move everything to one side. All right, you will write the related function by replacing 0 with the y. So dumb. All right, so instead of it being just equal to 0, we replace 0 with y. So y equals ax plus b. So in other words, in your head, I don't care if you remember ax plus b and all that fancy letters. All I care that you know is to move everything to one side and then write y equals in front of it. Okay? And then you'll graph the related function to find its x-intercept. Wherever it crosses the x-axis is the answer. All right, so let's try it. All right, so that flipped to the right. Okay, it was being weird. All right, so solve the equation algebraically. When I ask you to solve it algebraically, what does that mean? With algebra, just solve it. Okay, so if I asked you to solve, what would you do first? Good, distribute the 3. So 5x plus 2 equals, perfect. Okay, we have like terms on opposite sides, so I'm going to go ahead and subtract the 3x. So that'd be 2x plus 2 equals 6. Subtract the 2. 2x equals 4. Good, so x equals 2. So if you were to graph that, where would it cross the x-axis? It should cross at 2. Okay, so let's go ahead and take a look, just so you guys can kind of get used to how this works. So now solve the equation graphically by rewriting it into its related function and graphing. So again, anytime you see those words related function, you want it to be y equals everything else. Okay, so what do I have to do with this first before I can make it a related function? I have to set it equal to 0. So, but first I'm going to go ahead and distribute like I always do. So 5x plus 2 equals 3x plus 6. Do you want to move everything to the right, or you want to move everything to the left? I'd go left as well, because that way I have a positive x. It just makes more sense. So I'm going to move the 3x, and I'm also going to move the 6. Because I want to kind of get rid of all of that stuff. So I get 2x minus 4 equals 0. So to do the related function, you just want to set it equal to 0. And then instead of a 0, you're really going to replace that with y. So y equals 2x minus 4. Because when you're graphing something, you want an x and a y to graph it, right? And we always graph, remember, the y equals mx plus b. We're now in that form. So where does your first point go? Negative 4. So you're going to start by going down 4. And then what is my slope? What's my rise over run? 2 over 1. Good. So from that point, go up 2, left or right? Right 1. Up 2 over 1. And look where it crossed the x-axis, guys. Where did it cross? At 2. Did you get the same answer? Yeah. So if I asked you just to solve something, and I said, you can use Desmos, how easy would it be for you to solve something? Should say pretty easy, guys. All you have to do is type in the equation, and it'll solve it for you, right? It's going to graph it, and you can see where it crosses the x-axis, and those are your answers. All right, so let me give you one to try on your own, guys. This one says to solve it algebraically, and then check your answer graphically. Okay, so let me give you a minute, solve it algebraically, and then go back, rewrite it, y equals, and then graph it. All right, guys, real quick, we'll go through this. So we had 4x minus 12 equals 7x minus 21. So solving algebraically, I'm going to go ahead and subtract 4x. You could have went the other way, totally fine. So negative 12 equals 3x minus 21. Add 21. 3x equals 9, divide by 3. So we get x equals 3. So algebraically, we all should have been just fine there. So then switching gears, so I have to do it graphically, I'm going to come right back to where I was right here. If I just move everything to one side, so I already had subtracted the 4. I'll go ahead then and add 12. So I would get 0 equals 3x minus 9. So then I can replace that with y. So y equals 3x minus 9. Now again, if you went the other way, you could have had y equals negative 3x plus 9. Is that the same thing? Is that weird that we can go either way? Now wait a minute. Which way do we have to go? Does it matter? Let's look at this one, because that's the way I did it first, right? So if I graph this one, I would start at negative 9. And then my rise over run would be up 3 over 1. So where did it cross? Right at 3. But wait a minute, what if I do it the other way? What if I graph this one? I'd start at a positive 9. Then I go down 3, but over 1. My lines look different, but what do I know about where it crosses the x-axis? Same spot. So it didn't matter if you went to the left or moved to the right. It doesn't matter. You should still cross at where what the x equals. Okay? Which is kind of cool because I know some of you went one way and some of you went the other way, and some of you started to panic when I wrote that answer down to start with. Okay? But you can go either way. It doesn't matter. All right. So solving graphically by hand is not always easy or accurate, right? Like what happens if your answer is like x equals 3/2? Is that nice to find by hand? No, it's not. So what we can do then is use Desmos.